Well, hello everyone. I'm very glad to be here today, and this is I'm going to give a talk about RubyMotion. So my name is Laurent Sansonetti, and I'm the guy behind this project called RubyMotion. I'm a long-time Ruby enthusiast, so I've been using Ruby for about 10 years, so even before Rails existed. And actually it's funny because I don't even know much about Rails. I'm a programming language enthusiast, and I really like low-level programming. Like, I'm a C programmer on a daily basis, but my dream has always been to use dynamic languages for application development. And in the past, I contributed to the Ruby wrappers for the GNOME desktop environment. Then I was a maintainer of the RubyCocoa bridge, which actually allows you to use Ruby to talk to the Objective-C runtime. But RubyCocoa wasn't good enough for performance reasons, because it's a bridge, it's a middleware framework between two existing runtimes. So we decided to create the MacRuby project, which is a real implementation of Ruby on top of the Objective-C runtime. And that was my project for about 4 years. I was an Apple employee since 2004 to last year. At Apple, I work on iLife, OS X, and also the very core operating system layer that is used to power OS X and iOS. And MacRuby was one of my projects at Apple. And last year, I decided to leave Apple to do a startup and to move back to my home country in Europe, in Belgium. And the first product of the startup is RubyMotion. So it's a port of MacRuby, but for iOS. So it lets you do applications for iOS, but in Ruby. And the name of the company is called HipByte. So it's actually a play. It's hipsters bytes. Anyways, so who knows about RubyMotion here? Okay, not a lot of people. So what is RubyMotion exactly? Well, it's a toolchain that lets you write iOS applications in Ruby. So you can use the Ruby programming language to write applications for iPhone or iPad. It is different from the toolchain that Apple provides you. By default, Apple asks you to use Xcode and Objective-C. And Objective-C is a dynamic language. Well, it's a sort of a runtime on top of C that lets you use small-talk messages and define classes at runtime. It was great 30 years ago when you only had C++ as an alternative. Objective-C was a breath of fresh air. It was awesome. But 30 years later, Objective-C is pretty much old, and it's not very popular in the sense that most programmers these days don't know much about C anymore. So when I was at university 10 years ago, we were taught C and assembly. But these days, I have the feeling that young programmers don't know much about low-level languages such as C. And because Objective-C is a subset of C, a lot of programmers have a really hard time to get into iOS. So RubyMotion is really about trying to improve the learning curve on iOS. So it's basically Ruby to do iPhone applications. Why would you want to do actually iOS development? It's actually a very huge market. So according to Apple, there are 365 million iOS devices that have been sold since the very first iPhones, and about 400 million active iTunes accounts. So that's a pretty huge user base. And these days, if you do a consultancy, especially with Ruby, you can probably find a lot of contract work to do iOS development also. And it's also possible to sell applications on the App Store and try to make a bit of revenue. This is very interesting. This is the first RubyMotion success story. So RubyMotion was released about 5 months ago, but we already have this very interesting success story. Everclip is an application to to actually connect to Evernote. So it lets you clip information and send them to Evernote. It's completely written in RubyMotion. It's also the first commercial app. And I think I heard they are making some nice revenue now. So that's very very exciting. And they even won the Evernote Dev Cup. So if you want to check a real RubyMotion app in production, it's you can check out Everclip. What is RubyMotion exactly? Well, RubyMotion is an implementation of Ruby on top of the iOS frameworks. So I'm going to explain about that later. It's also a statically compiled implementation of Ruby. It's a dialect of Ruby that is completely compiled, completely transformed into machine code at build time. So it is very different from other dynamic languages. The entire toolchain is based on the terminal, so you only get to use the terminal to do everything. So you don't need to use any special IDE or user interface. You keep using your favorite text editor. So if you're familiar with Vim or Emacs, you just keep using these editors. And there is an amazing community around the project. So I will try to cover these 5 points in the presentation. First, let's talk about the runtime. The unique feature of RubyMotion is what we call the unified runtime. So RubyMotion implements Ruby at the same level where Objective-C, the Apple's language, is implemented, which means that in RubyMotion, the entire object system, such as classes and methods, are actually using the same runtime as Objective-C. So when you create a class in RubyMotion, it is actually an Objective-C class under the scene. And when you define a method in RubyMotion, it is also an Objective-C method under the scene. So why is it important? It's actually important because we get true native app development in this way and with no performance expense. So when you create an object in Ruby, and you pass it to an Objective-C API, and this Objective-C API calls your object back, there is no bridge behind both objects. So it's only native code, and there is no object conversion of any sort. So it's actually very fast. And we actually did this because I work for a long time on RubyCocoa, which is different. It's a middleware between two existing runtimes. And there were so many problems with middleware because you need to keep track of two existing object systems at the same time. You need to keep track of memory management in two different worlds. Here, this is very unique, so it's actually very nice for performance reasons. And also, in RubyMotion, the built-in classes, the built-in Ruby classes, such as string or array or hash, are actually using the foundation classes. So in Objective-C, you also have these built-in classes. You can create strings in Objective-C. And in RubyMotion, we use the same class for the implementation. So this is also great because it means that you can create classes in strings in Ruby and pass them to iOS, and there won't be any conversion needed. That's actually based on the little research that we did at Apple when we were working on programming language bridges. We found out that most of the types that cross languages are built-in types, such as string, array, and dictionary. So by making sure that these three built-in types are based on the same code, it gets much easier. So why would you actually want to use Ruby if you can already use Objective-C? Well, this is the basic hello world example in Ruby. If you don't know much about Ruby, this defines a hello class where there is a constructor that accepts an argument. And in this constructor called initialize, we set the argument to an instance variable. So the @sigil is actually meant to specify an instance variable. And then there is a say method that can be used to put hello what. And here we use string interpolation, which means that the value of what will be replaced. We actually replace what's happening in the string. So you will see hello something. And this is a very basic hello world example. And the same code in Objective-C would be more like this. And this does exactly the same thing. It creates a class with a property. It has a constructor. It has a say method that prints the content of the variable. And that's pretty much about it. So we could say that the core of this, the very important part of this code is only 3 lines. Everything else is boilerplate code. In Objective-C, when you need to create a class, you need to have a lot of code around it. You need to have two separate files if you want to do things the right way. And it gets pretty messy. In general, Ruby is a much more concise language, so it lets you have applications in a very short amount of code. One of our users ported all of his existing Objective-C apps in RubyMotion, and he told us that he was able to get rid of 60% of the code. So he only had 30% at the end, so which is awesome because you have less code means less bugs, right? So you write less code, it's easier to maintain. So we have more time to play video games. And this is an interesting snippet. I was talking about that RubyMotion is based on the Objective-C runtime, but it also lets you call pure C APIs. So if you're a C developer, you probably know that C is not a dynamic language, so it's very static. So you have header files that describe the APIs that you can use, but that's pretty much about it. So, and this is an example of RubyMotion using the OpenGL API. And OpenGL is a framework available in iOS, and many people use it to write games. But it's a pure C API, so it's only a set of macros, constants, and functions, and structures. But in RubyMotion, we develop a layer called bridge support, which actually parses the entire C-based frameworks and generate support for a static compiler, so that when you actually try to call a C function, the compiler is smart enough to know that it's going to be this specific C function in that framework, and it will replace the code with a direct call to the C function. So, and this is basically a one-on-one port of C to Ruby. And the very funny thing is that the guy who did this forgot to remove the semicolon at some lines, which is actually not required in Ruby. So you can, and all these things, like for instance, the GL clear color is a C function. The GL underscore color underscore buffer underscore bit is actually a macro, I think, a macro to something. So you can, I have no idea what this code does, by the way, but it works. So let's talk about the compiler. And by the way, this logo is the logo of the LLVM project, which is the most awesome logo ever. And RubyMotion is based on LLVM. So it's actually very interesting because, as far as I know, RubyMotion is the first implementation of Ruby that is completely statically compiled. So what it means that you only have one compilation build. So we transform the Ruby code into machine code, and then there is no more compilation anymore. So we don't do just-in-time compilation. We don't do code interpretation, mostly because these are pretty much black holes in the iOS guidelines rules. So we don't want to mess up with Apple. So the code that you write in RubyMotion cannot do code evaluation at runtime. So we only compile once. And we use LLVM for that. And I'm going to explain a little bit the compilation process. So first we start with the Ruby syntax, which is basically pure text. So here we define a hello view class that inherits from UI view, which is a iOS class. We define a method, and then we call the super method, and then we probably do some custom drawing stuff. And the compiler will parse this into an AST, which is an abstract syntax tree. Here I'm using a very simple notation, but it's basically an array of arrays. So it's actually a huge tree of tokens. And this is actually very common in programming languages. Most programming languages have an AST parser and compiler. And based on the AST, the compiler will generate a LLVM intermediate representation. So LLVM is, if you don't know what LLVM is, it's actually a set of modules to write compilers. So it's actually very cool. And it's also a language for these modules. The language that LLVM uses is called the intermediate representation. So it's some sort of generic assembly language that you can actually build this language and add instructions to it. And then all these LLVM modules will let you generate code, target any architecture you need for that very specific code. So based on the AST, we generate the equivalent LLVM assembly instructions. And we also apply a lot of optimization passes there. So we do a method inlining, we do dead code removal, we replace loops. We even have an optimization to do tail call elimination. So it lets you write functional code in Ruby,
which is nice. And after that, we can only target assembly for the proper architecture. We support two architectures: Intel 32-bit, which is required for the simulator, and then we have different architectures for this different iOS hardware, with ARM Buster 6, vSet, and vSet-S, the new iPhone 5 architecture. And based on the assembly, we can then get machine code, which looks like nothing, but nobody is going to look at the machine code. So this slide is, I remember it. So this is an application called Mustachio that I wrote with a friend of mine. It was actually the first RubyMotion app. We actually wrote this to make sure that Apple would approve RubyMotion applications. So it's actually a simple app. It uses core image to detect faces inside the picture. Oops, sorry. It uses core image to detect faces, and then on every face it adds a mustache. But it will grow the mustache according to the guy's face, and it's actually very interesting. So the code source is on GitHub, by the way. If you type Mustachio, you will be able to see it. But the application has been removed by Apple since, because I forgot to renew my Apple developer account, and I wasn't aware that they would delete your applications. That's pretty nasty. They send you an email, do you want to renew your account? And I say, well, no, I will create a new one. But I forgot that they would remove the app. So anyway, that's a very simple app. And the guy in the screenshot is my son, by the way. But what's interesting here is the size of the application. I'm not sure if you can see it, but the size of the app is 0.9 megabyte. So this is what I really want to mean with this slide. The runtime overhead in a RubyMotion app is very easy. It's less than 1 megabyte. Here it's 0.9 with some sort of compression, so it's pretty nice. So it's the compiler generates a very optimized code, but we really try to make sure that the final executable will be as short as possible. And we've been working towards reducing the code size by 300K less, but it's still pretty slow, I think. And this is also very different from other development platforms that add, for instance, 10 megabytes on your application. And I think if you go over 12 megabytes, you can't download applications from 3G networks anymore. So it can be an issue. So here we really try to make sure that the compiler is generating a very short code. Now I'm going to talk a bit about the toolchain. So the RubyMotion toolchain is based on the terminal. So you use the terminal for everything. And you use the terminal to create a project. And the project is basically a directory and in this directory there is a rake file. If you don't know much about rake and rake files, rake is the Ruby equivalent of make, the C-based. Usually make is used for C programs. And rake is the de facto build system of Ruby. And a RubyMotion project is basically a rake file that has 3 lines of code by default, because the entire project configuration has default values. So you can customize everything in the rake file, but by default it has sensible default values. And the rake file also has a bunch of tasks that you can use from the command line to play with the project. And the 3 most important tasks are the simulator task, which is also the default one, which will send the application on the simulator. There is a device task that will actually send the application on your device. And we can also start the application right away if you want to immediately see the application running on your device. And finally, there is an archive distribution task that will generate an IPA file suitable for App Store deployment. Since 2 weeks ago, we added debugging support in RubyMotion. So this is very exciting. I'm not sure if you guys know Dwarf. Dwarf is a debugging format originally written for C-based programs, so that it lets you add contextual information about your source code, especially for debuggers. And we actually support Dwarf in the compiler now. So when we compile Ruby code into machine code, this machine code has debugging information right away. So it means that we know, for instance, that at this very specific offset, we are talking about this Ruby method and this file and this line. So it's very useful for when, for instance, you get a crash trace in RubyMotion app, we can now annotate the crash trace with the file and line information of your project. And as far as I know, we are the only high-level language that support dwarf. We use you can attach a debugger. Here we use GDB, but we can switch to LLDB later, and we probably write a better debugger in the future. But you can attach the debugger on both the simulator and the device. You can set breakpoints, and you can inspect pretty much everything inside the debugger. And this is just a screenshot of a debugging session. Here we can actually set a breakpoint to somewhere in the Ruby file. Then we can continue the program, and then it breaks on the breakpoint, of course. And if I type BT, which prints the backtrace, you can see that the first line has information about the method name, and then the file and the line. So it's actually very, very useful. Another thing we do is that we do testing, and RubyMotion ships with something called Bacon, which is an RSpec-like framework. So it lets you write tests using an English-like language. So it's a sort of DSL for testing. And it's also integrated with the UIKit run loop, which means that all the tests will be executed when the application starts and these kind of things. And it ships with a functional test layer, which is the most important part of the testing part. So you can write functional tests, like for instance, tap this button, get the text field of this, get the value of this text field, and vice versa. So you can write pretty elaborated tests for your app. And you can also use test-driven development with RubyMotion. And this layer is based on UI automation, which is a framework Apple uses for testing. But the difference that at Apple, they force you to use JavaScript to write your tests, because you can't really use Objective-C to write tests. It's too low level. So, but here we don't want to use JavaScript because we already have Ruby. So it lets you write UI, it lets you use UI automation from Ruby, which is much better than JavaScript. And this is a snippet of a test using this new testing thing. So we can see that it reads like English, right? Describe the timer view controller, do tests. We test this very specific controller, then it has a timer label, do, and then we have test there. So that's supposed to be friendly for developers. We don't, this is, so do you guys recognize what this is? So this is Xcode. Xcode is the Apple's IDE. And we don't support Xcode by default in RubyMotion. First, because Xcode is a very bad editor for Ruby, and even for other languages. It's such a disappointment. It's very bad. For Ruby, it's so bad that if you use a regular expression inside your code, the parser will actually, if you use a reserved keyword inside the regular expression, it will stop parsing the rest of the file. Oh, sorry. And anyway, so the premise that of Xcode is that first it's maintained by Apple and it breaks a lot of time, so we don't want to rely on that. And also, Xcode is very magical. So if you have been using Xcode, you know that you can create user interface with interface builder, and which lets you create UI with your mouse, and then if you click somewhere else, you break something. And then you can create also core data models, which is a database of iOS with your mouse. But we don't really like that. It's actually great for Objective-C, because Objective-C is tedious. If you want to do things programmatically, it can get very annoying. But in Ruby, it's so simple. And in Ruby is a great language to write abstraction layers, also called domain-specific languages. So we are taking a different approach here, and we prefer people to do everything programmatically, so without using the mouse and magic. But in Ruby, the code can be much shorter. So I will show you that later. And it wouldn't be a real screenshot of Xcode without the crash. I'm joking. So you get to use your favorite editor in RubyMotion. And personally, I'm a Vim user, so it's the best editor ever. But people also use TextMate or the recent Sublime Text 2. Redcar is a very interesting editor. It's all written in Ruby using the gRuby implementation, and they have a very nice integration with RubyMotion. So you can create projects from Redcar, launch the simulator, the compiler, everything works. It's really awesome. And there is also Emacs, which is some sort of operating system. You can also use Emacs if you like, if you really like. RubyMine we are actually working with the JetBrains folks, which are very nice folks, by the way. And we are working about adding RubyMotion support to RubyMine. So it might come later. So if you're interested about that, you should follow their blog probably, and there will be an announcement. But the very interesting about RubyMine is that it provides auto-completion of the iOS APIs from a contextual perspective. So I did a few screenshots of the first beta at SMP. Here, if you just type UI_window.alloc.init, it will suggest you the initWithFrame method, because it's actually a method defined on UI view. But UI_window is a subclass of UI view. So you can select this suggestion, and you can keep working. You need to provide a rectangle for this method as an argument. So you start with the UI screen method, and then it suggests you to get the main screen, which is exactly what you want. So you keep, and then it suggests you to return the bounce method. And using the bounce method, we return the rectangle required for this window. So here, I just tried that this morning, by the way, and it's working awesomely. So I think that once this will be available, this will make the life of RubyMotion developer much easier. Now let's talk a bit about the RubyMotion community. Oh, that was fast, by the way. Last time I looked, there are about 500 projects on GitHub, mostly libraries or sample code, but also this editor support. So all this editor support is basically open source. The community around RubyMotion has been growing so fast. The first 2 weeks that the product was released, we got like thousands of developers joining and purchasing and using the platform. So it's actually very, very, very big. So I selected a few projects to show you today. TCAP is actually a very nice project. It lets you, it's a DSL for writing UI, but it uses the CSS convention in the sense that you write the presentation, the style from the presentation. So here you can actually create some sort of style sheet object that will contain the layout of the theme of your widgets, like for instance text fields or a search bar or buttons, and then you can apply this style sheet to a specific view controller. And all the elements from this view controller, we use this specific theme. So it can be very interesting. And this is much better than using the iOS APIs. Bubble Wrap is an interesting project too. It's a very interesting project that provides a lot of small wrappers around tedious iOS APIs. So here, for instance, they have the Bubble Wrap HTTP post method that lets you do HTTP post. And if you want to do this programmatically, you need to use I don't even remember the name of the class, but it's like 10 lines of code. Here in just one line, and you pass a block, and you have your HTTP post request, which is awesome. And then you can use the JSON wrapper to parse and also generate JSON. So that's pretty nice. For motion, lets you build the kind of UI that you see on the right using a hash. So this is extremely useful. If you have been doing a bit of iOS development, you probably know that doing this UI programmatically is very, very complicated. It's some sort of table view with custom cells. It can be very, very tedious. And here it's just a hash that you pass to an API and you're done. So I'm not sure why you would want to do this programmatically then. Parse model is an interesting project. It's a wrapper for the parse.com service. So parse.com, if you don't know it, it's some sort of remote key value data store that you can use to as the backend of your application. So you can set values in the cloud and get values from the cloud. And this is a Ruby wrapper for it. So it looks a bit like Active Record if you use the race. You can define a class, then you can say that it's actually going to be a model for parse. And then you can set the fields. And then once you create the post, once you hit the save method, it will save the object in the network, and then you can retrieve it later. So that's actually pretty nice. And yeah, the last project I wanted to show you is the motion state machine project. So it lets you write state machines in RubyMotion. So honestly, that's not my thing, so I have no idea what this code does. But it's actually, so you can actually create a state machine and plug it into the iOS event loop so that when a notification arrives, it can enter a different state in the machine. But what's very interesting is that the entire library is actually based on GCD, Grand Central Dispatch. GCD is the concurrency library that Apple ships with iOS and also OS X. And RubyMotion provides a wrapper for GCD, but it's not that great. And this entire thing is all based on GCD. So all the callbacks are synchronous, they will be concurrent. So, and RubyMotion is also an implementation of Ruby that doesn't have a global interpreter lock. So everything can be run concurrently. So I think that's going to be a very interesting project in the future once iOS devices get more CPU cores. And now I will show you a demo of RubyMotion. So let's start with a new project. So I will just go on TMP, okay, and I will just create a new project called Hello. And as you can see, it created a bunch of files. Hello rec file is the project configuration. Then you have this app directory that has by default a file. Then you have resource, which is empty. This directory should contain all the image and sounds and fonts and whatever, all the resource files that your application needs at runtime. And then the spec directory contains the tests for your application. So if you want to do a test-driven development, you can start right here and write the tests. If I enter the directory and I type break, it's going to compile oh, that's weird. It's going to compile my application and then run it on the simulator. Oops, here we go. So my hardware is pretty slow today, so I don't know what's happening. But we have the application running here, and it's an empty window. So why is it empty? Because by default we don't generate much code. So if I show you the application delegate method, you can see that it's just a basic method that returns true. So we don't do much here. So what I can do is I can start by I can create an RL view. I can show the I can set a message for the hello view, and I can then run the RL view. Then if I type break again, oops, what's happening here? Since we updated to Xcode, yeah, you see the hello go to here. Since we updated to Xcode 4.6, the simulator takes like 3 seconds to launch, so I'm not sure what's happening here. So that's basically hello world. And now I'm going to show you a more interesting sample. I'm going to show you the timer application. It's one of the first samples that we built with RubyMotion. It's taking a lot of time to start the simulator. Okay, here we go. So this is a very simple app, and it has a label, a button. Once you click the button, it starts a timer, and when you stop, it stops. Very simple app. Here, what's interesting is that you can see that we have a prompt here. It's actually what we call the REPL, and it's a Ruby interactive console where we can type expressions. And these expressions will be compiled using just-in-time compilation and then sent to the application using a Unix pipe, and then executed inside the simulated application. So you can introspect everything in the application using a command line. So this can be very useful, especially when you deal with core data. You can introspect the content, the application running. And a very interesting feature of RubyMotion is that it lets you, if I maintain the command key and then move the mouse over the simulator, as you can see, I can see the views inside the simulator, And for instance, if I select the main view, and if I click on it, the shell is, I get the shell back, but the contextual object is now this specific UI view. If I type self becomes the UI view of, that's the view I selected. So I can, for instance, ask for the background color, and it says nil because there is no color, but I can assign to a new color, right? Oh, there is no, that's a gray color, like this. And I can basically change the application at runtime. This is something you can't really do in Objective-C. It's very complicated. And you can use this also for rapid development. For instance, you can start your code, you can place widgets, but you don't really know where they should go. Then, for instance, I can select my label here. I can check the frame. It's 22,000. Okay. So I can set the frame to something different, like, oops. Like this. You can see it move a little bit below. Up. I can basically reposition my widget. So this can be very interesting. Now I would like to show you the debugger. So if I type break with the debug command 1, it starts the debugger, and then we are running inside the debugger, and the application is running. I can at any time break, and then I can set breakpoints. If I want to set a breakpoint to the timer controller, as you can see, I just use the tab space, and it knows that there is this file in the project. I can break on line 32, for instance, which is okay. It doesn't know that. So let's see first. Oops. You know what? The best way is probably to make a mistake in the code. So if I go here, and yeah, for instance here, I have invalidate. I'm going to remove one letter. I save the file. Now if I run it inside the debugger, this is the method that will be called when the button is clicked. So here I'm running, and it's working because I haven't clicked yet. So if I click, boom, I click the second time, and it breaks here. So it breaks when raising an exception. So if I ask for the backtrace, this is the backtrace where the exception is raised. And we can see that we are triggering method missing, which is a Ruby exception. But here we know that we are actually here in timer control 26. That's where the exception is raised. So if I go to this line, this is exactly where we are. So we know that this is where the bug is. So I can change a line and do OK. And from here, I can select the frame 7, and now I'm in the Ruby code. I can print the Ruby code, and I can also view, introspect what's happening. If I check for the, I can check for the timer object, which creates an error because it's it has been invalidated. Yeah, because it's nil. Yeah. Anyways, the debugger is nice because you can actually see you can actually set breakpoints, inspect variables. And the last thing I wanted to show you is the Spec Framework. So in this example, we have a bunch of specs that we wrote. So we wrote the specs after the code, so it's not following test-driven development. But you can write the specs before if you feel it's if you can sleep better at night. And so I'm just going to run the specs first. So if you type respec, it will rebuild the application for a specification mode. Then it will build the spec library. So it only happens once. And then it starts the spec, and up. boom, and it actually exited with 0 failure and 0 errors. So it ran all these four specifications. So you can't really automate. You can automate your application. So this is actually very cool. If I show the source code, you can see that it's here. I can tap the start button. I wait for 1 second. Then I tap the stop button. Then here we check if the text of the label is below 1 and before 2, which means that it should actually have waited 1 second. So you can actually write a very nice set of tests around your applications. And yeah, I think that should be it. If you have any questions or if you want to see anything more, let me go back to the slides and yeah. Yes? Yeah. So the memory management is the same as Arc in Clang. So we do you don't need to care about retain and release. I mean, you don't need to think about retain counts in RubyMotion. So the runtime will appropriately release and retain your objects, and we do this at runtime. So except that Arc does this at compilation time. So it's basically like, it feels like garbage collection. But it's not true garbage collection in the sense that the objects will only be released when the nearest auto-release pool is destroyed. So RubyMotion is really based on the same memory classes than Objective-C. Yep.
I had a question about integrating Objective-C libraries.
Yeah.
Is that supported?
Yeah.
Doable easily?
Yeah. So you can. So I haven't talked about that, but you can integrate any third-party library. So it's very easy. You can do it 2 ways. First, the first way is to do it manually, so you can embed the Xcode project inside your application. And the second way is to use CocoaPods. And we integrate with CocoaPods. And actually, the guy who does CocoaPods is actually a friend of mine. So we try to make sure that it works great on RubyMotion. But yeah, so, and if you don't know what CocoaPods is, by the way, it's some sort of package management for Objective-C libraries. So it's actually very nice. And in RubyMotion, you can install a pod for a specific framework, and it works.
Another question. Is any part, because honestly, this is awesome. This is really, really good.
Thank you.
So I'm so impressed. And now the other question. Is any part of this going to be open source? Because I see the value in what you're doing, but I'm also seeing a number of derived tools that could be so useful, partially to some of the stuff we're doing.
Yeah. So
The interactive mode, for example, is jaw-dropping.
yeah. So for instance, right now the entire toolchain is open source, except the compiler and the runtime. So all the command line stuff is open source, so people can hack the source code. But the runtime and the compiler is still proprietary. But yeah, so we actually open source the rest of the code a month after the launch, because many people ask for it.
Yeah, so I guess you could buy a RubyMotion license and build tools based on your license and the open source tools.
Yeah.
The other question was the interactive, the REPL.
Mm.
Does it run with device?
It doesn't work on the device yet.
All right.
No, it doesn't work on the device yet. But yeah, it's possible. Yeah, but it's actually going to be tricky because it's tricky for a technical point of view. We use the LVM just-in-time compiler in the REPL, and you cannot use just-in-time compilation on iOS because it doesn't allow you to mark memory page as executable. So, but we will try to find a way to work around that. But it's only for development, so Apple doesn't need to know.
That's perfect.
Yeah. Any more questions? Yeah. Yeah. So right now we haven't really looked at that. So we know you can use instruments, which is Xcode, a profiler on RubyMotion apps, and it will work more or less out of the box. Because we Objective-C, RubyMotion objects are Objective-C objects. So you can see for instance, you can see all the objects that have been created. You can see the name, and the name corresponds to the Ruby class. So that works. And also, when you get a call trace for every allocation, object allocation, because we support the dwarf stuff I was talking about, it means that you can see where in the Ruby code this object has been created. So that works. If you can use instrument, I think, but the problem is that instrument is pretty much unusable in my. You cannot use it for a big application. It gets very slow, and I'm not sure if you really want to use that. But what we would like to do is to write our own profiler at some point, which would be also more higher level. Because Ruby developers don't really want to know about low-level objects and backtraces and these kind of things. It's like the debugger. The debugger right now is very low level. I mean, you need to know GDB and about backtraces and things. And Ruby developers are not really familiar with that. So we want to build a higher level debugger. Oh, and I forgot to mention, we support dtrace too. So there are dtrace probes in the runtime. So you can dtrace exceptions, messages, object allocations, these kind of things. So that can be used to also profile, for instance, what's happening when it's in infinite loop. Yeah. One more question. Yeah. Yeah. Yeah, so that's the #1 feature request. So, yeah, we are considering doing it, but I prefer not to talk about it until it's done. So we don't want to. It's preferred. Yeah, we know that a lot of people want it, so we are probably going to look into it. But once it will be available, we'll make an announcement, perhaps. Any more questions? Yes?
Okay, you said this was a subset of Ruby. What constraints are like the most important constraints?
Okay.
Separate out.
Okay, so yeah, well, so I think there are two big constraints. The first one is eval. You can use eval with a string. And the second one is that it's a statically compiled Ruby. So the require method doesn't work in RubyMotion. You need to provide all the files at build time. And these are the two big constraints as far as I know. So you can use everything else. So the first builds, we didn't support a defined method, but we fixed that. So eval with a string and require. They are not going to work anytime soon, I think. More questions? No? Okay. Well, thank you very much.